So let's go for the next thing then, which I told you that we will be going for the next topic, which won't be able to complete in the session we were doing yesterday. So this is about resistivity now, resistance and resistivity. I hope you still remember about the resistance, right?
Yes.
What is resistance?
It's something that opposes the like something that
Mhm.
opposes
That's
the
very
action.
true.
To stop the motion of an object.
Mhm. So what in this specific scenario, how can we say this is resistance?
Sorry?
In this scenario, when we are working right now, do you see my screen, right?
Yes, I can see your
Okay.
screen.
So when we see here, resistance, if you remember, yesterday I told you resistance is opposition to the flow of current, right or not?
Yes.
So it's not only the simple opposition, it is opposition to flow of current because we are dealing with electricity now, right? Am I clear?
Yeah. Yes.
Okay. And the other definition we have said that the resistance is ratio of what?
Ratio of potential difference in current.
Yes, PD and current. So in symbol forms, we say R is equals to V over I. Am I clear?
Yes.
Now, when we are dealing with resistance and resistivity, we have to keep in mind two different relations. First of all, that resistance is proportional to the length. And this proportion is direct proportion, right?
Yes.
That means resistance is proportional to the length. Longer the wire, larger the resistance, right or not? Smaller the wire, shorter the wire, smaller the resistance. I can show it to you like this, If we have a wire this much length and the same sort of wire, same diameter, but length is short, right? So this says that the upper wire will have a longer length, right? Right? And larger resistance, high resistance. Am I clear? This is
Yes.
having a low resistance because its length is less. Is that clear? Now, second thing, resistance is inversely proportional to area of cross section. Area of cross section means through which current starts to flow, enters the wire. This area is called the area of the cross section, right? That is, R is proportional to 1 over A. Am I clear? So it means larger the area, smaller the
Yeah.
resistance, smaller the area, larger the resistance. For example, we have two wires. One is having larger area like this one, cross-sectional area, right? And the other one is having the same length, but the area is the smaller, like thinner pipe is there. So in this case, this one have low resistance and this one is having high resistance. The reason is quite obvious that if we have a thinner pipe, water will not flow very conveniently, right? And if we have a wider pipe, water will move easily. Am I clear?
Yes.
Okay. If I combine both of these relations, we say R is proportional to L over A. I'm combining both of them in one equation. And I told you yesterday, whenever proportionality sign will be finished, we have to place a constant of proportionality. And here this is rho. This is read as rho. And this rho, sometimes we are using for density. But when there is mass and volume involved, here there is length and area. So this rho is actually resistivity, right? And its value depends upon the material because different materials have different resistivity, right? Its value depends upon the material we are using or being used. If I would like to get the value of the resistivity, means the formula of the resistivity, we can make subject of the formula as rho. This A will go to the other side and obviously cross multiplied. So RA, this L will go down. So we can say resistivity is RA over L. Am I clear? Any questions so far? Yeah.
No.
Okay. So SI unit of resistivity is ohm meter. Ohm meter. Because this is area, so meter square, this is length meter. So one is cancelled out and resistance is ohm. Am I clear?
Yes.
Clear. Any questions so far?
No.
So you can take a picture of this if you are okay with it. Then I'll give you a table in which different materials will be having different resistivity situation, right? Higher the resistivity, greater the resistance, because here you can see that they are in direct relation. So lower the resistivity will have the lower resistance. And as we discussed yesterday, that we will be using those cables which have less resistance so that current flowing is maximum, right?
Okay.
So we will be using those materials whose resistivity is less. Am I clear?
Yes.
Okay. This is
I'm
symbol for the resistivity. We can say it is rho, right? This is the length of the wire. Here, this is the length of the wire. A is the area of cross section, this area, right?
okay.
Because we are combining this and this together. This is multiplied over here, this is divided. So when we make them combined, L will be up and A will be down. As it is. Yes. No. Cross, no crossing is there. They are just multiplied, nothing else. Yeah. Yeah. Anyone, no problem. Got it, Isaac?
Yes.
Did you take the picture?
Yes.
Okay. So now the next thing we are using, that is the table of the resistivity of different materials. And we will discuss that, why we are using this one and why we are not using this one. Okay. Let's see this one.
Oh,
This is the table of the materials, resistivity of different materials, right? I'm making this table and you will see that why we are using copper always. Because whenever you see in the television ads, we see that they are focusing more on the this factor that we should be using the copper cables always, right? Did you
Yes.
ever see that in the television, you know, advertisements while watching the
Yes.
cricket match? Did you ever see that? They're asking you to use the copper cable and this cable and the Pakistan cables.
Yes.
The
I
reason
think
is,
so.
sorry,
Yes.
because the copper is the one which has the minimum resistivity normally in use with us. So we have silver, we have copper, we have tungsten, we have iron, we have nichrome, we have graphite, and we have polythene, right? And its resistivity is 1.6 into 10 power minus 8. Silver. Copper is 1.7 into 10 power minus 8. And this is in ohm meters, okay? So don't worry about that.
Okay.
Ohm meter, okay? The next one is 5.5 into 10 power minus 8. Next one is 9.8 into 10 power minus 8. 49 into 10 power minus 8. Nichrome is actually 100 into, sorry, this is 100. Nichrome is 100. And graphite is 3500 into 10 power minus 8. And polythene is about 10 power 16. Very high, right? This is about. Now, the actual thing here with us is that we are using some of them, which are, this one is here, or this one is here with us. These two normally we are using because the rest are having very high values. Now, the question comes to us that why this, silver is having less resistivity as compared to this one. Why we cannot use silver? What comes to your mind? What's the reason? This is a question I have. Why silver cannot be used? But the material we are using for the less resistivity, we focus on this, that the resistivity should be less. But instead of silver, we are using copper.
Silver is expensive.
Very good. This is a very good option. Do you get it, Aiza? Aiza? May I hear from you? Aiza, do you hear me? Aiza, are you there?
Can you hear me?
Yeah, now I can hear you. My question was why silver cannot be used, although its resistivity is smaller than copper. What could be the reason?
Because
Did you ever see somewhere the people using the silver cables in their houses? Right? Because silver is expensive, bit. Copper we can afford. We normally, if people do not afford to buy gold, they go for the silver jewelry, right or not? Can I hear from you? I'm sorry, I'm unable to hear you. Yes, Aiza bete.
Could you hear me?
Yeah,
I
I can
answered
hear you
it.
now. The reason is because silver is expensive, right or not?
Yes.
Do you get that? That's why we normally do not use the silver cables in our houses because it's going to be very much expensive. Am I clear? It's not cost effective.
Yeah.
It's not economical. You may use many wordings for this, right?
Mm.
Is that okay? Is that okay, Bete?
Yes.
So the question here is that in an electric fire, 15 meter of nichrome wire of resistivity this much. So this could be somehow like this, we are using the element somehow like a spring. Am I clear? And the length of the wire used in this whole length of the wire, the length is 15 meters. Am I clear? And the
Yes.
resistivity of the nichrome is 100 into 10 power minus 8 ohm
Okay.
meter. He is asking, question is, A part, calculate the resistance of the nichrome wire given that the cross-sectional area is 2.0 times 10 power minus 7 meters square. So we are looking for the resistance. Do you remember in the previous board, we have written R is equals to rho L over A, right or not?
Yes.
Remember that the length is always supposed to be in meters and area is supposed to be in meters square, always, right? And fortunately, it
Okay.
is there in that unit. So we don't need to do any sort of conversions. Rho is 100
Oh,
times by 10 power minus 8. Length is 15. Area is 2 times 10 power minus 7. If you have calculator, please let me know what do you get from there. What is the resistance?
um, can I just go get the calculator?
Bring it, please. This value now.
75.
Sorry, 75 ohm. So this calculation says this is 75 ohm. Now in B part, he says if the nichrome wire is replaced by the copper wire and the resistivity of the copper wire is 1.7 into 10 power minus 8, right? Now he is asking
Yes.
calculate the resistance of this wire if the length is still the same, area is still the same. There is no change in the area and in the length, right? What's going
Yes.
to be the new resistance? Again, we'll be using the same formula and we will be calculating the resistance, right? So it's
Yes.
1.7 times 10 power minus 8, length is 15 divided by 2 into 10 power minus 7. What comes now?
1.275.
So can I write it 1.3
Yes.
after rounding off? Now, can you see that the resistance of the nichrome was 75 and resistance of the copper is 1.3. And if you can see that this element we are using for the heating purpose, right?
Yes.
So we need the element to have a very high resistance because if it has a low resistance, when more voltage and current will be provided to it, it will melt, right?
Yes.
So we can say that copper is not suitable for making this element. Copper is not suitable for making this element because its resistance is too low for an heating element. Am I clear? Is it clear to you? Is that fine, Bite?